right, in this video, we're going to talk about what happens if we have a negative rational exponent. So we've talked about negative exponents in the past. Remember, if we have x to the negative 2 power. Remember that raising to an exponent means that we're going to take this base and we're going to multiply it the number of times our exponent is. So we're going to multiply x a negative 2 amount of times, which doesn't really make any sense, right? It doesn't make sense until we make that negative exponent into a positive exponent. You remember our rule that anytime we have a negative exponent, we can make it into a positive exponent by dropping it down to the other side of that division bar, taking its reciprocal. So I have 1 over x squared is the same thing as x to the negative 2. So now, if that exponent is a negative and it's a fraction, it's a negative rational exponent, we would have to do the same thing. It wouldn't make sense for us to have a negative 1/2 power. We would have to make it positive first, bringing it down to the other side of that division bar. And then I have 1 over a to the m over n. And then I can convert it into radical if I need to. But now at least it's positive, and then I can simplify it a little bit easier. Let's do some examples. If you look at example number 5, it asks us to write an equivalent expression with positive exponents and then simplify if possible. You notice in A that I have 9 to the 1/2 power. It doesn't really make much sense. I can't convert it to radicals because I have a negative in the front there. And I don't know what 9 to the negative 1/2 power is until it's positive. So let's make it positive by dropping it down. I have 1 over 9 to the 1/2 power. Then I might have to convert it a little bit because I'm still not sure what 9 to the 1/2 power is until I convert it into radical notation. So I'm going to take that denominator and I'm going to convert 9 to the 1/2 into the square root of 9. So now I have an equation or an expression that says 1 over the square root of 9. And I know that the square root of 9 is really 3. So I can say that 9 to the negative 1/2 power is the same thing as 1/3. Not negative 3, but positive 1 over 3. All right, look at B. B says I have the quantity 5xy raised to the negative 4/3 power. As soon as I see that negative exponent, I don't like it. I want to make it positive first by dropping it down, making sure that I keep my parentheses, and then I can try to convert it into radical to see if it'll help me simplify any more. Remember, top dog goes in the house. But if you notice, when I convert it into radical and I have this exponent of a 4, that really means I only have 4 of these expressions. That's not quite enough to look for groups of 5, so I wouldn't be able to simplify it anymore. So I would either just leave my answer like this, or I can leave it in radical notation and have it look like this. All right, what about C? C says I have 64 to the 2/3 power. I'm not sure what 64 to the 2/3 power is, and I really don't know what 64 to the negative 2/3 power means. Let's make it positive first, always, 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 by dropping it down. Then I can convert that 2/3 rational exponent into radical notation. Top dog goes in the house. Then I can simplify the cube root of 64 squared. I probably want to stay away from 64 squared. That's a pretty big number. I'm going to do the cube root of 64 first. What times what gives me 64? I ended up getting 4, and then I can take 4 and square it. That gives me 16. Now my answer isn't 16. Remember, it's 1/16. Very different. All right, the last two in this video. D says I have 4x to the negative 2/3 and y to the 1/5. I have a couple different bases, none of them like terms, like bases, but I do have some negative exponents that I don't like. I notice that this x is raised to the negative 2/3 power. The 4 isn't. He has an invisible 1 exponent, and I like that. And I like the y to the 1/5. He's positive. I just don't like that negative 2/3 exponent. So let's take the base that's raised to the negative exponent and make that negative exponent positive by dropping that piece down. I want to leave the 4. I want to leave the y to the 1/5. I just want to drop the x to the 2/3 down to the denominator so that it becomes a positive exponent. You could try to convert it into radicals and see if it'll simplify, but I don't think any of those terms will. So you can go ahead and leave it just like it is. All right, E. E has a fraction raised to the negative 5/2 power. Now, you could distribute the negative 5/2 to the numerator and denominator, but then they'll both have negative exponents. If the top numerator has a negative exponent, we would make it positive by dropping it down. And if the bottom has a negative exponent, we can make it positive by bringing it up. Or can I just flip it right away? As soon as I bring the numerator to the top and the denominator to the bottom, we have a 7s over 3r. And what I've just done is I've just made my exponent positive. You notice that I flipped the base, but I did not flip the exponent. You can't double flip. You can only flip and make the exponent positive. So be careful with that. Sometimes students accidentally flip both, and that's not correct. All we're doing is making sure that we're changing this negative exponent to positive by moving the numerator to the bottom and the denominator to the top to make that exponent positive.